Hi, Trig students. Goodness. This is our very last video together, and I'm so sorry I didn't get to tell you goodbye. But we need to get you finished with this class so you can move on. Let's talk about your test a little bit. So your test is going to be in my math lab. Even though you no longer have access to your homework and your quizzes, if you click on the My Math Lab link there on the left, and then you click on your assignments, the only thing that will show up is the final exam. And so you will click on that. Each of you will have a different final exam. There will be 24 questions, but the questions will be randomly chosen by the computer from a pool of 93 questions. And so the department has really stepped up their game with these final exams. And so I love you, and I went through all 93 Trig questions. So Teacher of the Year over here. I could not make a study guide with all 93 questions because that's ridiculous. But I did make a study guide, which is this here, of I think 42 questions. Is that what we ended up with? Yes. That covers every type of question. And if there's a type of question, like you can see here on number 1 and number 2, these are both the same type of question because it's finding arc length S, but I put 2 of these on here because each one presents a different issue. So you have at least one of every type of those 93, but sometimes you'll have more than one if there's another issue that pops up. So as we're going through these, I'm going to kind of talk about some possible issues that may come up so that you have a better idea of what to expect on the test. But the test is completely multiple choice. I don't think it's anything horrific. It's just there's so many possibilities that you could have a lot of different tests. And so that's what's a little worrisome to me. It's not what you're used to. Okay, let's jump right in here then. So you are going to need your graphing calculator, and you are going to need a unit circle, even if it's just on your phone or on your computer. Okay. All right, so we're going to start at the very beginning, very first day of class, and go through all the way through chapter 9, dealing with vectors and dot products. Okay, so it covers the whole thing. Here we go. Okay, first question. Now this is a strange little drawing, which is why I drew it for you. It kind of looks like a megaphone, like what a cheerleader might use. But this is supposed to be a circle, and this is supposed to be a little wedge taken out of the circle, okay? We've never used drawings like these before. We always used, you know, a complete circle like this, and then I would kind of put my wedge there and talk about it. Well, they just took the wedge out and blew it up. So I wanted you to kind of see that so you're comfortable with it. They want you to find S. S is arc length. So if you recall, this is the formula for arc length. R is going to be radius, so it's either this length or this length, same thing, and it does not matter the units. What does matter is this angle in here, this theta. This has to be in radians, has to be. If it's not, you have to convert it to radians. So that's the issue with number 2. All right. On the final exam, they simply want a decimal, okay? So they want you to use your pi button on your phone and give them a decimal and round it to 3 decimal places. So if this is our formula, S is going to equal R, which is 20, that's our radius, 20 centimeters, times theta, which already happens to be in radians, and then multiply those two together. So in your calculator, 20 times pi divided by 4, and round it to 3 decimal places. Now that's all that's required, but just so you do know, this arc length is the same unit as your radius, so that is going to be in centimeters, okay? All right, number 2, very similar question. The reason that we're doing this one in addition to this is because some of you are going to get this question, which is very straightforward. You have radians. Excuse me. This one has degrees, not okay. You cannot put degrees into your formula. You're going to have to change this to radians, okay? So must be in rads. So if you recall how to do that, we're going to take 40 degrees and we are going to divide it by 180 degrees, because really what you're doing is multiplying it by pi over 180. Okay, we're going to reduce that. So in my calculator, I'm just doing 40 divided by 180. I get that funky little decimal there. So I'm going to go to math, frac, and this gives me 2/9. Now you're going to have to throw a pi in that numerator. That's your radian measure, 2 pi over 9, okay? Don't forget to put that pi in there. All right, so now we're ready for our formula. We have a radius of 8, happens to be in meters, it doesn't matter. And we have a theta now that we can use, which is 2 pi over 9. Multiply those together. I don't know why, but I went to 2 decimal places here. Okay. And there we go, and that's our answer. Okay, so just be aware of this little situation. If you get the degree problem, divide it by 180, put that in your calculator, hit math, frac, it'll give you the fraction, and throw a pi in the numerator. Okay? All right, number 3. An object is traveling around a circle with a radius of 17 feet. If in 40 seconds, okay, that's a time, a central angle of 1/5 radian is swept out, what is the linear speed of the object? Well, if you recall, linear speed is this funny little equation there with gamma. It's r theta over t, okay? There's actually a lot of versions of this, but this is the version you are going to want on your final. So we have r, we have t, and then theta is this strange little measurement right here, 1/5 radian. So if you recall with that, we take that as our theta, 1/5 radian. We do not put in a pi, we do not change it, we simply take it as 1/5. That is our theta, okay? And so now we are just filling in what we have. Okay, just like that. 17 times 1/5 divided by 40. All right, let's put that in our calculator. I'm going to have 17 times, I'm going to put 1/5 in parentheses and hit enter, divided by 40. Here's my decimal. They want this particular problem as a fraction. Always read your directions on there, right? So I'm going to go math, frac. There's my fraction, 17 over 200, okay? That's all that's needed. Now, if you wanted your units, just to make sure you were on the right track, we had 17 feet divided by seconds. So this is feet per second. That is your linear speed right there, okay? All right, that's page 1. If I can get it off. Okay, there we go. All right, so 4, 5, and 6 are all extremely similar. We are going to do them to death to make sure that no matter what kind of problem you get, you are comfortable. So the directions are exactly the same for each one of these. I just copied and pasted. So here's what they say. In the problem, t, because they don't use theta here, remember sometimes we replace that with a real number, is a real number. And the point, xy, is a point on the unit circle that corresponds to t. Find the exact value of the indicated trig function. Exact value means no decimals. That's what it means. Exact value means it wants a fraction every time for here, okay? All right, so now you need to use your knowledge of the 6 trig functions. So here we have x, here we have y. We are on the unit circle. which means that this x also corresponds to cosine, and this y also corresponds to sine. The unit circle mentioned means that r is 1, so we don't have to worry about a radius. We know this is cosine, this is sine. Okay, this wants you to find secant of t, or secant, using these values. So hopefully you remember that secant is the reciprocal of cosine. That's the key. So if secant is the reciprocal of cosine, then all I have to do in order to find secant t is to take my cosine, which is root of 17 over 3, and flip it. So I end up with 3 over the root of 17. All I had to do, okay? Now I can't leave it like that. I do have to rationalize. That's going to give me 3 root of 17 over 17. And there's my answer. Okay. All right, let's try the next one. Okay, same situation. The point is a little different. I put in a negative here. So again, this is going to be cosine. This is going to be sine because it says we're on the unit circle. We don't have to worry about dividing that by an r. Okay, now we want cotangent of t. Okay, so if you recall, cotangent is the reciprocal of tangent, but I don't have tangent, so that's not super helpful. What I do know is that cotangent is cosine over sine, or x over y. And here's x and here's y. Okay, so if I do cotangent of t, x over y, or cosine over sine, I get root of 17 over 3 divided by negative 4 over 3. Now I can do a keep, change to multiplication, flip, or I can notice that those cancel. Yours will too. This gives me root of 17 over negative 4. Now I always like my negative in the top. You can put it anywhere you want. And I don't have to rationalize because my root is in the top. So there's my cotangent, okay? So you need to make sure that you're remembering all of these little guys and how they relate. All right, here we go. Next one, we want to find cosecant. And again, we're on the unit circle, so this is cosine, this is sine. Cosecant is the reciprocal of sine. So that means when I find the cosecant of t, I'm just going to take sine and I'm going to flip it. So I'm going to have 3 over negative root of 5. And again, that negative can go anywhere, but I do need to rationalize. So I'm going to move my negative to the top. I just like it there better. I'm going to get 3 root of 5 over 5. And there we go. Okay, so I did 3 of these problems because I wanted to make sure you understood how to do these 3. If this said tangent, okay, make sure that in case you were to get one that said tangent, you remember that is sine over cosine. So I would have this in my numerator, this in my denominator. My 3's would still cancel, but you're going to end up with negative 4 over the root of 17. And then you're going to have to rationalize it, right? And you're going to get negative 4 root of 17 over 17. That's what that would look like if you had tangent. Now, cosine is just the first one. Sine is just the first one, okay? But make sure you can find all 6 of those given this point when it asks for exact value. Okay, number 7. Number 7, gosh, I could have just done this, for a million problems. I just picked 4. The directions are going to say without using a calculator. Well, a calculator is not really helpful anyway because they are going to want on here exact answers. Okay, no decimal. That's what that means by without using a calculator. So you're going to need a unit circle unless you have memorized these. All of your answers are going to be right here on your unit circle, right? Remember that the first number of the point is cosine, The second number of the point is sine. So here we go. Cosine of 60 degrees. Here's 60 degrees. Cosine's the first one, 1/2. Okay. Sine of 45 degrees. Here's 45 degrees. Sine is the second number of the y, √2/2. Okay, no decimal. All right, now we get a little bit more complicated. So remember, right off of here, cosine is your first number in the point. Sine is your second number in the point. Okay, tangent of pi/3. Remember, tangent is y/x, or sine over cosine, however you want to think about it, right? So tangent of pi/3, I go to pi/3. I'm going to have to do a little calculation. Here's my point. I'm going to take y/x, or sine over cosine. So I'm going to have √3/2 divided by 1/2. These are going to cancel nicely, and I'm going to end up with √3. Okay, didn't have to rationalize a thing because my root was in the top. Secant of 45. So remember, secant is the reciprocal of cosine. So I'm going to look up cosine of 45. That's what I'm going to do first. Cosine of 45 degrees, here's 45, here's cosine, is √2/2. I want the secant, which means I'm going to flip it. Okay, so I'm going to have 2 divided by the √2. I can't leave it like that. I'm going to have to rationalize, and I get 2√2/2. Those cancel. And my answer is just going to be the square root of 2. So of course there could have been an infinite amount really of these particular kinds of problems. So just make sure you have your unit circle handy. Make sure you understand how to get them. If it asked for cosecant, we would have taken the sine value and done the reciprocal. Cotangent, we would have done x over y, or cosine over sine. All right. So just be prepared to answer those kind of questions. And again, it is multiple choice, and watch out for positives and negatives depending on what quadrant that you're in. Okay. All right, moving right along. Number 8. Number 8 gives us sine and cosine. Okay. Then it wants to find the exact value of the trig functions. Well, just so happens I want the reciprocals of each of these. So here we go. Now, if you notice, these are not unit circle values, but we don't have to worry about that because all we want are the reciprocals anyway. So secant is the reciprocal of cosine. So if I want secant of theta, I'm going to take the cosine of theta and I'm going to flip it. And I'm done. Nothing to worry about for him. The cosecant of theta is the reciprocal of sine. So I'm going to take the sine and I'm going to flip it. Now he has a radical that's going to be moved to the denominator. So I am going to have to work on him a little bit. I'm going to get 7√5/5. And there we go. Easy enough. Okay, now let's build on that. This next one's a little bit more complicated. Now we're given secant. It's -7/2. That is not a unit circle value. It doesn't mention unit circle either. And it tells us that theta is in quadrant 3. That's important. Find tangent of theta. Okay, so since this is not a unit circle value, how do I know that? Because it doesn't say it's a unit circle. And also because secant is the reciprocal of cosine. So if I flip this over, I would need to find a cosine of -2/7. And that is not a value that's on here. Okay, tangent is y/x. Those are the two values I'm going to need. Secant, because it's the reciprocal of cosine, cosine is x over r. Secant is r over x. So the information that I have is that r is +7 and x is -2. Okay, how do I know where that negative goes? Because r is always positive, always positive. So if there's a negative, it's got to go with the x. Also, because I'm in quadrant 3, and in quadrant 3, x is negative and y is negative, right? Everybody's negative in quadrant 3. Okay, so I need to find y. I know my x, but I need to find y. That's where the lovely little Pythagorean theorem comes into play. Okay, I know my r, I'm going to square it. I know my x, I'm going to square it. I do not know y. Okay, so 49 minus 4 is 45. That's y squared. I'm going to take the square root of each side. 45 is going to give me 3 root of 5 for my y. Now, if you're not so sure about that, remember you can always break them down using these little trees. I'm looking for two numbers that are the same. Pull out a 3, I'm left with a 5 under. Okay, now be really careful here. Is this going to be a positive y or a negative y? Quadrant 3, negative y. That's super important, okay? Because you better believe that on your multiple choice test, it's going to give you the tangent with a positive value and a negative value, and you're going to need to know which is correct. Quadrant 3 means x and y are both negative, okay? All right, so now we have everybody we need. We're going to put in the y. We're going to put in the x. We're going to reduce, which really just means negative divided by negative is a positive. And there's our tangent. And that makes sense because remember, all students text constantly. Text for tangent in the third quadrant, it's supposed to be positive, and it is because we have a negative divided by a negative. So you may not have this exact question. You may have cosecant instead. If you have cosecant, you're going to be given r and y, and you're going to have to solve for x, figure out if it's positive or negative, plug it in. You may be finding for cotangent. In that case, it would be x over y. Okay, so this is one of those problems that unfortunately there's just so many possibilities, but the gist of it is that use this information with your quadrant and the Pythagorean theorem and get as much info as you possibly can. Then figure out what you need for your answer and plug that in, okay? All right, let's try number 10, okay? Same situation, 11, same situation, okay? We're gonna try it, we're gonna keep going for both of these. Make sure that we have done this as much as we can, okay? All right, same directions. This time I have cosecant, and I'm in quadrant 2. Okay, let's think about this for quadrant 2. Quadrant 2 is gonna have a negative x and a positive y. You know what? I'm going to even write that. Negative x, positive y. And down here, I should have written negative x, negative y, just so I make sure that I do that. Okay, so we had already mentioned that cosecant is the reciprocal of sine. Sine is y over r, so cosecant is r over y. Okay, now since my cosecant is 5/3, my r is 5, and my y is 3, okay? I need to find x because cotangent is x over y. I have y, but I don't have an x. So I'm gonna use Pythagorean theorem. I'm gonna square 5. I don't know x squared. I'm gonna square 3. My y here is going to come out to, I'm sorry, my x, 25 minus 9 is 16. That's x squared. Square root of both sides, x comes out to be 4. In quadrant 2, x is negative, so I need to make that a negative 4. That's really, really important, okay? All right, now cotangent is x over y. And I don't need to reduce. There we go. Okay. All right, let's try it again. This one's has a little twist here because look, I didn't tell you what quadrant this was. Anybody know what quadrant 270 to 360 is going to be? Here's 270, here's 360. That's a quad 4 situation. Okay. And in quad 4, we have a positive x and a negative y. So x is positive, y is negative. And of course, r is always positive, so we don't ever have to worry about that. All right, let's see what info we have. We were given tangent. Okay, so if you recall, tangent is y over x. Okay, so from this information, I can put in y and I can put in x. Now there's one negative. Who is that negative going to go with? That's where this comes in. In quadrant 4, x is positive, y is negative. So I'm going to put the negative with the 4. Okay. Now we want to find cosine. That's x over r. All right, I have x, but I do not have r. So here is Pythagorean theorem. All right, I'm going to square 3. I'm going to square negative 4. R squared is 25. That leaves us with r is 5. Remember, r is always positive. So cosine of theta is going to be x. X is positive 3 over r, which is positive 5. And there's my answer for cosine. So make sure that you understand the role that the quadrants play in there. That helps you figure out who's positive and who's negative. Also make sure that you know how these 6 trig functions break down in terms of x and y and r, and that you use the Pythagorean theorem to find those answers. All right, moving on. Now we're looking at inverses. Okay, so we're in chapter 7, just starting chapter 7 here, looking at inverses, making sure we understand how those work. We're going to need our unit circle again. All right, we have 3, 4, 5 inverse problems. 5 inverse problems, then we start solving equations. All right, let's see if we can remember who the quadrants that each one of these is valid in. Okay, so if you recall, sine is allowed to have a value for an inverse in quadrant 1 and quadrant 4. This is where sine is allowed to be. Here's the positive values, here's the negative values. It can't go over here. Remember hot lava, it's got to be here or here. So I'm only allowed to be in either quadrant 1 or quadrant 4. Now I notice here that this value is negative. So since this is negative, I'm in quadrant 4 for this guy, okay, since he's negative. So what I want to know is what value for theta in quad 4 gives me negative root of 3 over 2 for sine. That's what I'm looking for. That's what that means. So negative root of 3 over 2 down here for sine is right here, 5 pi over 3. Now there's a problem, okay? Remember, this is great. This is exactly what I'm looking for, but I cannot write 5 pi over 3 because in order to get 5 pi over 3, I had to go through quadrants 2 and 3, and I'm not allowed over here. Remember, hot lava. So the only way I can get down here is if I sit here and I go the opposite direction, which is negative. So I've got to go this direction. And remember, I just take a negative of the denominator. So instead of positive 5 pi over 3, my answer is going to be negative 1 pi over 3 because I'm going that direction. Okay, so here we go. So the answer to sine, the inverse of sine of negative root of 3 over 2 is negative pi over 3. That's what I'm looking at. Okay, that's my answer. All right, let's talk about cosine. Cosine inverse is only valid in quadrants 1 and quadrants 2. Remember, cosine's up here. Sine's down here. All right, so positive values would be quadrant 1. This is a negative value. This negative value means I'm in quadrant 2. So now what I'm looking for is what value of theta in quadrant 2 gives me negative root of 3 over 2 for cosine. Okay, so I'm over here in quadrant 2. I'm looking at the cosine values, negative root of 3 over 2. That would be 5 pi over 6. And I'm allowed to come this direction to 5 pi over 6, right? I don't have to worry about going this direction. With cosine, you're allowed to just go whoop, right over here. So 5 pi over 6 is my answer. And there we go. Okay. All right, let's look at number 13. 13 is find the exact value, okay, again, so just one of these like this, no decimal, of the inverse cotangent. Okay, so what I'm going to do is move my paper over here and let's talk about inverses. Inverses, that's what that says. Well, I'm trying my best. There, okay. So quadrants 1 and 2 are going to contain cosine and his reciprocal and cotangent. Quadrants 1 and 4 are going to contain sine, his reciprocal, and tangent. Okay, so this is how it breaks down. These guys, you're allowed to have, you will only have positive angles. Okay, these guys, you will have positive angles for quad 1, negative angles for quad 4. Remember how we had to go backwards for sine. Okay, so this is the breakdown. Cosine, secant, cotangent are up at the top half, quadrant 1 and 2. Sine, cosecant, and tangent are the right half, quadrants 1 and 4, and you will have negative angles with these guys. Okay, so knowing that information, let's go back to number 13. What is the exact value of the inverse of cotangent of negative 1? Okay, cotangent is quadrants 1 and 2. This is a negative value, so quadrant 2. Okay, so what I'm looking for is inside quadrant 2, I'm looking for a situation where cotangent of some theta is going to equal negative 1. So cotangent is x over y. This means I need the same value for x and the same value for y, except one's positive, one's negative. That's going to reduce down to negative 1. So over here in quadrant 2, I need the same value for x and y that's going to reduce down, one negative, one positive. This is going to do it. And this is 3 pi over 4. Okay. So my theta in this situation, or I guess I could write it the other way. I could say that my inverse in this situation is going to be 3 pi over 4. And that's because at 3 pi over 4, this is my point, right? And if I put x over y, they reduce down to -1, which is what I was looking for. All right, let's move on to this one. In tangent inverse, I'm looking in quadrants 1 and 4. This is a negative, so I'm in quadrant 4. I'm looking in quadrant 4, okay? Now, tangent is y over x. I'm looking in quadrant 4 for the point y over x that's going to have a root of 3 in y so that it will put it in the top, okay? And they're going to have opposite signs. So I want the point that's going to have root of 3 in y. All right, here's quad 4. Here are my y values. Here it is, root of 3 in y. Okay, let's make sure this point works. Okay, so if I have this point, let's make sure he works. I do negative root of 3 over 2 divided by 1/2. These cancel. Sure enough, that's the point I'm looking for. So what is the angle for this guy, for that point? That angle is 5 pi over 3. I can't use that. Remember, if I'm in quadrant 4, I have to have a negative angle. So it's going to be negative pi over 3. If this were your point, it would be negative pi over 4. If this were your point, negative pi over 6. Okay, so that's how it works. Negative pi over 6, negative pi over 4, negative pi over 3. You just take the denominator. All right, so this is going to be negative pi over 3. And there we go. All right, let's do one more. Let's just do a little bonus one that I just want to make sure you're comfortable with. I'm going to stick it up here at the top. So here's just an extra little bonus problem, okay? I shouldn't say bonus because you don't get bonus. So here's an extra. Okay, what if I give you inverse of tan of 0? Well, that's a funny situation, right? Okay, so tangent inverse allows me to be quadrant 1 and quadrant 4, okay? Well, neither one of these is going to give me a 0. I need to look at a quadrantal between these two, okay? Now, tangent is y over x. In order to get a 0 out of a fraction, there has to be a 0 in the fraction. And the 0 has to be in the numerator, right? Because if the 0 is in the denominator, we're undefined. So I'm looking for some point where y is 0. I don't even care what x is. I'm looking for the point where y is 0, and I want to be a quadrantal. So I'm allowed to go from here to here. So there's 3 quadrantals here. Y is not 0, y is not 0, y is 0. This is where I am. So what's the point, or what's the angle right here? 0. Okay, so the answer to this whole thing would be 0. Okay, because I'm actually looking at the point 1, 0, and that theta would give me 0. All right, so just a little reminder there of some inverse situations. Okay, the last two that you see here for inverse, the 15 and the 16, they want you to use your calculator. Finally, some calculator work, right? They want you to do 3 decimal places. Now, anytime that you're using the inverse, they want you in radians. Please, 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 they're not going to tell you that. Please make sure you are in radian mode for both of these. So I'm going to go to mode. Sure enough, I'm not. Hit enter. I'm in radian mode. Okay, this says inverse cosine. So remember that second cosine, negative 0.2. There's my answer. I go out 3 decimal places. I'm going to have 1.772. Okay. Done. Okay. All right, this one. I'm in radian mode. Second sign, that's inverse sine. Here I have a fraction. -2 divided by 5. There's my answer. To 3 decimal places, -0.412. Now, if you recall, when we were learning how to do this in our calculator, cosine's easy, sine's easy, tangent's easy. The inverses of those, or I'm sorry, not the inverses, the reciprocals of those are not quite so easy, and cotangent's a real pain in the butt because you have to actually use cosine. You do not have to worry about those. Make sure that you can, in your calculator, handle inverse cosine, inverse tan, inverse sine. That's all you have to worry about. You don't have to do any of those reciprocal ones. Okay, now we're going to move on to solving an equation. You're going to have 2 equation solving problems. So we're going to have an entire rotation to do that on. The key is going to be to isolate the trig function. So in this case, I'm going to add √3 to both sides, and I get cotangent theta equals positive √3. So what I'm asking for is which thetas, and it's probably more than one, do you get a cotangent of √3? Well, cotangent is actually x over y, or cosine over sine. So in order to get a √3 in the top and nothing in the bottom, I need to have a point where I have a √3 as part of x. That's what I'm looking for, okay? I also notice this is a positive √3, which means that either x and y are both positive or they're both negative. Whoops. But you're not going to have a mix, okay? So we want x and y to both be positive or x and y to both be negative, and we want a √3 as part of my x coordinate. Okay, that's a tall order here. All right, √3 is part of the x coordinate. They're both positive. Pi over 6 is one of my answers. Okay. All right, I go over here. Now here's √3 part of x, but one's negative, one's positive. That's not going to work. Here's √3 part of x. They're both negative. A negative divided by a positive, nope, that's not right. A negative divided by a negative gives me a positive. And that value is 7 pi over 6. Okay. And then last but not least, here's a √3 over 2 is x, but his y is negative. That's not going to give me a positive cotangent. So these are my 2 answers. Okay, there we go. And if you wanted to see those worked out, what I was looking for was either that point or that point. And if I put one over the other, they're going to reduce down just like these did right here. And you are going to end up getting x over y, and you'll end up getting just a positive √3. Okay. All right, one more equation. Solve the equation on the interval. So we have one rotation and we're using radians. We want to isolate sine theta. So I'm going to subtract 4. I get 2 sine theta equals 1. We're going to divide by 2. And I get sine theta equals 1/2. Okay. Now, I'm looking for the point on the unit circle where sine theta is positive 1/2, or where I have a positive 1/2 in the y place, right? That's what I'm looking for. Okay, so I take my unit circle. Well, here's a positive 1/2. That's pi over 6 again. And notice I don't even care what x is. I'm just looking for a positive 1/2. Here's a positive 1/2. I don't even care if he's positive or negative or what he is. That's 5 pi over 6. Okay. I do not have a positive 1/2 in quadrant 3, and I do not have a positive 1/2 for sine in quadrant 4. So those are my answers. Okay. Those are the equation problems you're going to have. You will not have anything that has 4 answers. You're not going to have anything that's multiple rotations or that has a 2 theta or a 3 theta or anything complicated like that. This is just a real simple review or simple final. All right, you are going to have one identity. Not really an identity, more of a simplify. This is it. It's all you're going to have. Want you to simplify that down. So make a note on this one that you understand how to do it, because that's the one you're going to have on the final. Okay, no equal sign here, so we're just simplifying. First thing you're going to do is FOIL. Okay, you're going to FOIL this guy out. You're going to get a 1 minus cotangent theta plus cotangent theta minus cotangent squared theta minus cosecant squared theta. Okay, these are going to cancel. You get 1 minus cotangent squared theta minus cosecant squared theta. Okay, well, if you look at this and feel like a Pythagorean identity could help you, then you are correct. You are correct. The Pythagorean that you're looking for looks like this. It's kind of strange. I had to rearrange it, but this is the Pythagorean that you're looking for. Okay, the 1 minus cosecant squared theta equals negative cotangent squared theta. All right, so I'm going to rearrange this guy a little bit. I'm going to do 1. I'm going to move this over here by the 1. Okay, and I'm going to put the minus cotangent squared theta in the back. Okay, so I have 1 minus cosecant squared theta. I'm going to change that to a negative cotangent squared theta. And I have a minus cotangent squared theta right there. These can combine and you get negative 2 cotangent squared theta. And this is the simplified answer that they want. That's what you're looking for. Okay. All right. That brings us to number 20. Okay, number 20 says find the exact value of this expression. Now, I gave you a hint. I said use sum and difference formulas. Unfortunately, on your test, it's not going to tell you this. So hopefully you will be on your toes and you will realize that this is not a unit circle degree, right? That is not on the unit circle. And if it's not on the unit circle, you're going to have to take 2 values and add them, or 2 values and subtract them and make that value, okay? That's what you're going to have to do. So be aware of that. All right. Now, here's the other thing that we're going to do. We have tangent. There are 2 formulas, right? Can you see this if I were to write this down here, maybe? Okay. So we have the formula for sum for tangent, okay, which looks like this: tangent alpha plus tangent beta over 1 minus tan alpha tan beta. This is if you wanted to make a sum of degrees to give you 285, okay? We can also make a minus, a difference of alpha minus beta, okay? That's going to be tan alpha minus tan beta over 1 plus tan alpha tan beta, okay? So here are your 2 formulas to keep in mind. You need to write those somewhere so that you have them. I tend to always add rather than subtract. I don't know why, it's just kind of my go-to thing. So I'm gonna use this one. Just be aware, this one is also fine. Okay, so make sure you have that somewhere. All right, so here's what I'm gonna do. I need to get 285. Well, 285, using degrees off my unit circle, could be 240 plus 45. That's just what I'm going to use. You can use anything you want, right? So my alpha is going to be 240 and my beta is going to be 45. Here we go. So alpha of 240 plus 45, okay? I'm just using this one right here, okay? I'm going to have tan of 240 plus the tan of 45 divided by 1 minus tan of 240, tan of 45. Okay, now I'm going to have to go to my unit circle, and I'm going to have to look up the tangent of 240 degrees. Well, here we are. Here's x or cosine. Here's y or sine. I'm going to do this over this. Now, some of you can automatically look at that and say, great, that's a positive root of 3. If that's not what you can do, that's okay. Okay, let's do it together. We're going to have y over x. These are going to cancel. The negatives go to positive, and I get root of 3 over 1, or just root of 3. Okay, tan 45, here's 45, y over x, they're the same, okay? They're going to cancel down to a nice positive 1, okay? So there's my y, there's my x. They're just going to cancel completely, and I'm going to get a 1. Okay, so now for my denominator, I'm going to have 1 minus. We already said tangent of 240 was root of 3, and we already said tangent of 45 was 1. It's going to give me root of 3 plus 1 over 1 minus root of 3. All right, we can't be done. We can't stop here because we have a radical in the denominator. So if you recall, this was a bonus question back on test 2. What we have to do is multiply the top and the bottom by the conjugate of this guy. So I'm just going to change my sign, and I'm going to do 1 plus root of 3. By multiplying top and bottom by the conjugate of the denominator, that just means changing that middle sign, I'm going to eliminate any radicals that I have in that denominator. This is going to be, I'm going to FOIL out now, root of 3. Root of 3 times root of 3 is 3, because that's like a root of 9, and that would be 3. Plus 1 plus root of 3. There's my numerator. Okay, can you see that okay? Move it a little. Okay. All right. In my denominator, I'm going to have 1 plus root of 3 minus root of 3. There's that canceling we wanted. All right, be careful here. Negative root of 3 times a positive root of 3 is a negative root of 9, which is 3. Those are going to cancel. In my numerator, I'm going to have 4. Root of 3 plus root of 3 is 2 root of 3. 1 minus 3 in the denominator is negative 2. I have that magic triangle that means I can reduce. I'm going to divide everybody by negative 2. It's going to be a negative 2 minus a root of 3 is my answer. If I divide this by negative 2, I get negative 2. If I divide this by negative 2, I get minus 1. If I divide this by negative 2, I just get a 1 in the bottom. And that's the answer that I'm looking for. Okay. All right. There you go. All right, one more of these sum and differences. Okay. one more of these. Here we go. I'm gonna kind of move this up a little bit so that I don't have to look at that writing. It's distracting me. Okay. Then I think I'll take a break and upload this first video, and then we'll come back and do a second video for the chapters 8 and 9. Okay. This 21 will finish up chapters 6 and 7. Okay. Find the exact value of this. Well, what in the world is that? That, ladies and gentlemen, is a difference formula for sine. So let's write some more formulas down, shall we? Okay. In addition to those formulas, this was left over from Trig, stats. Okay. In addition to that tangent sum and difference formula, we need to write down some other sum and difference formulas because, again, there's 93 questions and who knows what you're going to get. So this is the sum formula for cosine. Make sure you have that at your fingertips. Okay, can you see that? Nope, it went too far. How about that? That's better. Okay. All right, let's write down the difference formula for cosine. And this way, no matter which one you get, you can do this. Okay. We already wrote down the tangent sum and difference formulas. Here's the cosine, and then let's do the sine. Here's the sine difference formula. Okay. And here's the sine sum formula. That doesn't look quite right to me. I already wrote down the sine sum formula, the minus formula. Hold that thought. Guess what I'm doing? I'm gonna go back here to chapter 7 and look at sum and difference formulas because that doesn't quite look right to me. And my brain has just kind of been fried. So hold tight for a second. You can be writing while you're waiting. How's that? And let me make sure that I get this right. We don't have any double angle or half angle formulas, so I'm not worried about that. Okay, but here it is. All I had to do was put a plus, but I was just scared. I screwed up the college algebra one, so I don't want to screw up yours. Okay, there we go. Those are the other four formulas you need to have down. So number 21, all they want you to do is match this with one of these. That's the goal. So if you notice, first thing I see is a minus, okay? That narrows it down to this one or this one. Then I notice I have a mix, sine, cosine, minus, sine, cosine, minus, cosine, sine. So this is a form of a difference of signs formula. That's what that is. So I'm going to write that here. Sine alpha cosine beta minus cosine beta sine alpha. All right. So my alpha is pi over 2. Okay. My alpha is pi over 2. I screwed this up. I told you I'd figure out a way to do that. Okay, there we go. This is alpha. My beta is 3 pi over 4. There we go. So this is this right side of the equation. What you want to do is now write the left side of the equation. So sine of pi over 2 minus 3 pi over 4. Okay, well, I want to combine these, but they don't have the same denominator. So if I take pi over 2 out here to the side and I try to make him have a denominator of 4, I'm going to multiply top and bottom by 2. So I'm going to have 2 pi over 4 minus 3 pi over 4. This is going to give me sine negative pi over 4. Okay, this is what I'm looking for. I'm looking for the sine of negative 5 pi over 4. And then once I find it, that value is my answer. So I have worked completely backwards. So what I originally did, I took the degrees here for tangent, I broke them up, I put them through the formula, and I came up with a value. For this problem, I have the formula. You could keep on going with the formula if you want to. You can find sine pi over 2 and multiply it by cosine 3 pi over 4, okay? Minus cosine pi over 2 times sine 3 pi over 4. You're going to get exactly the same answer. If you just want to keep on working through this, you can. Sine of pi over 2 is 1. Cosine of 3 pi over 4 is negative root of 2 over 2. That came right off my unit circle. Cosine of pi over 2 is 0. Sine of 3 pi over 4, root of 2 over 2. Those cancel, and you get negative root of 2 over 2. That's fine. That's your answer. Go for it. What they were wanting you to do, and they're not going to know if you do it or not, is to go through like this and put in your alpha minus beta, get a value, go to your unit circle. Where is negative pi over 4? Well, negative pi over 4 is right here. It's 7 pi over 4. What's the sine value? Negative root of 2 over 2. There's your answer. So you could have gotten it either way, okay? So if this, there's no telling what this is going to be, but it's going to be one of these 4. So make sure that whatever it is, you're prepared and you have those 4 formulas written down somewhere, okay? All right, that is exactly half of our study guide, right? Because there's 42 questions on the study guide. That ends chapters 6 and 7. So I'm going to take a little break and upload this video, and then we will come back with a part 2 and we will do the rest of the study guide. So I'll talk to you soon.